Lecture 4 is mainly divided into parts. The first part is single-stage switches, and the second part is about staged switches. In the first part, we will talk about crossbar switches, mainly focusing on definition, advantages and disadvantages, handling crossbar output port contention. In electronic, a crossbar switch is a collection of switches arranged in a matrix configuration. A crossbar switch has multiple input and output lines that form a crossed pattern of interconnecting lines between which a connection may be established by closing a switch located at each intersection the elements of the matrix. The advantages of crossbar switches are as follows. It has simple structure. It is suitable for circuits or packets. It has low latency, which means minimum number of connecting points between arbitrary input and output. There's no internal blocking, and multicast is easy with electrical crossbars. However, there are also a amount of disadvantages of crossbar switches. It has low scalability, and there's no fault tolerance for crossbar switches. In order to handling crossbar output port contention, we offered 3 implementations. Internal buffering, buffers at output, and a block at input. In part 2, we will mainly talk about clock and Bayesian switches. There are potential benefits for staged switches. It has fewer cross points than in a crossbar switch. It has diversity of paths, thus leading to a lower blocking probability and increased reliability. Clock switch. Each switch of a stage connects to each switch of neighboring stages. The photo here shows a simplest clock switch, which has 3 stages. The advantages of clock switches are as follows. It can switch circuits. It has diversity of paths. It has fewer cross points for large P. Clock switches are used in commercial products, such as Juniper T-Series products. Bayesian switch. Self-routing using binary representation of output port. Bayesian switches require the fewest cross points. However, it suffers from the potential bar blocking, and it is typically limited to packet switching. We will introduce types of Bayesian blocking and the ways to deal with Bayesian internal blocking. There are 2 types of Bayesian blocking, internal blocking and output port blocking. Internal blocking is contention for an output port of a component switch in one of the early stages. Output port blocking is contention for an output port of a switch in the last stage. In order to deal with Bayesian blocking, we provide buffering within the switching network. It offers multiple planes of later switched stages. It moves traffic blocked in one plane to higher plane. However, it is expensive because the number of switches in each stage increases exponentially with stage number for the worst case.